Hi everybody, thank you for joining us today. My name is Kevin Weiner and I will be the moderator on this webinar. I'm excited to be joined today by Joe Peters, a solutions engineer at Harris Corporation. During the presentation today, Joe will discuss the new features and functionality in the newest version of ENVI, version 5.3, and how they can help you improve your geospatial analysis. If you have any questions at any point during the webinar, feel free to use the question area of your GoToWebinar dashboard. Joe will try to address as many questions as he can at the end of the webinar, and if he doesn't get to your question, he will follow up with you. And now I'm going to turn things over to Joe.
All right, thank you, Kevin. Thanks everyone on the line for taking the time to attend our webinar on what's new in ENVI 5.3. This is an exciting release for us, as you'll see throughout this presentation. I have a lot to go over because there's a lot packed into this release. There's a lot of tools for working with LiDAR data, so we've added a lot of out-of-the-box functionality for LiDAR in the core ENVI product. And we've also added a lot of tools for working with multi-temporal data sets, so you'll see that as well. This webinar will be a mix of slides and live demonstrations which show some of my favorite new capabilities. At the end of the presentation, if there's anything I've missed, there are quite a few things that didn't make it quite into the presentation. So I'll provide some links to our webpage where you can find more details about all of the things that have been included in this release of ENVI, as well as what's new in IDL, which is our programming language. So we'll also save a little bit of time at the end of the webinar to answer any questions you might have about what is presented today. Before I get started with what's new in ENVI, I just want to begin by briefly going over our solution stack. So we provide a myriad of solutions for utilizing and supporting efforts in information exploitation, satellite imaging, and climate monitoring. And at the foundation of our solution stack is our programming language, IDL. It's a powerful language for accessing, manipulating, visualizing raster data, and data in a variety of complex scientific data formats. And ENVI, which we're talking about today, is built on IDL, and it provides a powerful, easy-to-use graphical interface for accessing data in all kinds of geospatial data formats. And one of my favorite things is the fact that ENVI is built on IDL, and so that means that anything IDL can do, ENVI can too. So ENVI has a powerful object-based API, which is written in IDL, and this can be used to leverage custom algorithms, to run batch processing, create custom extensions, and deploy image analytics in enterprise environments, which we're starting to do more and more of these days. So we also have a professional consulting group here in our Boulder, Colorado office, as well as other places that can help you tackle unique and complex geospatial tasks. So unique things that you're trying to do that might take a little more legwork. Maybe you need help with just one component of a larger system. We can help you with that. And last but not least, we have Jaguar, which is a cloud-based solution for storing, accessing and managing large volumes of geospatial data. All right, so let's go ahead and get started with what's new in ENVI 5.3. In ENVI 5.3, we continue the tradition of providing best-in-class support for remotely sensed data formats and global change monitoring platforms. So some of the basics that I want to talk about today, just the things that we are always kind of keeping up with every release. So we have some new operating support in ENVI 5.3. We officially now support Mac OS X Yosemite and Windows 10 operating systems. And our engineers have also put ENVI through a rigorous set of tests to ensure that all ENVI ArcMap interoperability is supported in ArcMap 10.3. So for enterprise solutions, we also have the ability to host our image processing and analysis algorithms in ArcGIS for server as geoprocessing tasks. And so I just wanted to mention that. I think it's something that maybe a lot of folks don't even know. So if you do have an ArcGIS for server instance and you want to learn more about that, please contact us maybe after the webinar and we can go into more detail with that with you. So we also now support OGC geopackage vector features, and we have also made enhancements to our export to geospatial PDF capabilities. So that was included in the previous release, but now we have just a little bit more functionality with that. You can choose to export just the view extent of what you're viewing in the ENVI display, or you can export entire raster layers to geospatial PDF. All right, so with every release of ENVI, we make it a priority to ensure that we're keeping up to date with the new and emerging sensors that are out there that have been launched and where we're getting data that comes down from these satellites, we want to be sure that as soon as the data is available, that we can pull it into ENVI and start working with it. So to that end, we've added support for Pleiad and Spot imagery in native format. We also now support Deimos 2, DubaiSat 2, and SkySat products in the new Google data format. And so one of the more interesting developments in remote sensing, in my opinion, is the successful launch of Sentinel-2A. The Sentinel-2 mission is a land monitoring constellation of 2 satellites that will provide high-resolution optical imagery, provide continuity for Spot and Landsat missions. So this is a really cool mission. It'll provide global coverage of the Earth's land surface every 10 days with one of the satellites and every 5 days with both satellites in operation. So in ENVI-5.3, we're now supporting multispectral imagery from the Sentinel-2A sensor, which we're now starting to get data from. So I think this is great news, and I look forward to working with this data as the catalog of imagery grows. And on this slide here, I just wanted to show, I actually found this this graphic on the NASA webpage, and it just shows you how essentially the various different bands, the multispectral bands aboard the Sentinel-2 multispectral imaging sensor align with Landsat 7 and Landsat 8 sensors. So you can see that there's a lot of overlap between the spectral bands, and this will provide us a lot of ability to essentially take imagery from both of these sensors and be able to work between them. This would be really handy, for instance, when we're doing any sort of multi-temporal analysis, which I'll be talking about quite a bit later. So moving on to the third dimension, I want to talk now about our ENVI LiDAR integration. At ENVI 5.3, the ENVI LiDAR application has been fully merged into ENVI. And so what that means is we used to have a standalone product called ENVI LiDAR. It required a separate license to run. That's no longer the case. So now ENVI, core ENVI, has significant out-of-the-box point cloud visualization and analysis capabilities. So this includes the ability to generate digital elevation models, digital surface models, contour lines, and several other products right out of the box. And so you also now have programmatic access to LiDAR point cloud analysis capabilities directly through the ENVI API, and I'll talk about that a little bit more in a couple of slides. So first off, just wanted to show on this slide, I'm showing some products that have been generated out of the box with ENVI. So we've taken our point cloud, we can create digital elevation models, surface models. We can create within ENVI, we can pull our elevation model that's been extracted, and we can create hill shades, we can create slope and aspect. There's a lot of different products that can be generated now right out of the box. And then this example below is an example of creating a height model. So if I have a surface model and an elevation model, and I subtract the elevation model from the surface model, I then get an idea of what the height is of any features off of the bare earth surface. And I'm actually going to demo a quick example of how that might work in ENVI and ENVI LiDAR. So that's the out-of-the-box capabilities. We also have fully merged the ENVI, what was formerly the ENVI LiDAR API, is now fully integrated into the ENVI API. So previously, this was a separate API. It was still built on IDL, just like the ENVI API is, but it was separate. You had to call it separately. It was required a different license to access those routines that are specific to LiDAR. Now all of that is rolled into ENVI, and so this allows a lot of really neat kind of things to happen. So number one, you don't have to call different products. You don't have to have a separate license. And then number two, we can do sort of data fusion here. We can extract things from point clouds, get raster images, use all the power of ENVI to then do additional processing, all within one contained API. So this is pretty interesting. And the last thing I want to talk about, what was formerly ENVI LiDAR, did have some proprietary feature extraction algorithms available. So in particular, the ENVI LiDAR capabilities included the ability to extract buildings, trees, and power lines automatically from your point cloud data. So what we've done in this release is to roll these feature extraction algorithms into the ENVI feature extraction module. So the ENVI feature extraction module formerly was capable of doing object-based feature extraction from two-dimensional raster data. Well, now it's 3D, so we can also, in addition to doing the object-based feature extraction from raster imagery, we can now extract three-dimensional features like buildings, trees, and power lines from our point cloud data. And last but not least, on the topic of LiDAR, I just wanted to mention our web LiDAR viewer. This is part of our ENVI services engine, which is our method of essentially hosting our image processing algorithms in a cloud or enterprise environment. We're shipping that now with this pretty handy web LiDAR viewer, and I might, after my quick demo here, I might pop up a screen and just show you what that looks like live. So let's go ahead and move into our first demo here, where I just want to briefly show you some of these capabilities that are available now with ENVI with regards to LiDAR data out of the box. All right, so here we are in ENVI, and the first thing I'm going to point out is that we now have several ways to launch what is essentially formerly ENVI LiDAR. It's still a separate GUI that pops up, but there's a lot of different ways to open it now, and it doesn't require a separate license as it did in the past. So number one, we could launch it the same way we did previously. Even though it required a separate license, we could always go into our NV53 folder and launch the ENVI LiDAR GUI in that way. So that's one way that we can open it. Another way we can open it, it's now in the ENVI toolbox. So under the LiDAR folder in our ENVI toolbox, we can select Launch ENVI LiDAR, and that launches the LiDAR GUI in that way. Pretty cool. But I'm going to show you my favorite now. So ENVI has drag and drop capabilities with remotely sensed data. So if you have a metadata file that points to maybe Landsat imagery or worldview imagery or what have you, you can simply drag and drop that imagery into the ENVI display. ENVI will read it and open it the way you would expect. And so in this release, we can now do that with LiDAR data, and I think this is pretty cool. So there's a couple of different files that we could drag in. We could either drag in individual LAS files or a set of LAS files. But when LAS files are opened in ENVI LiDAR, essentially a project is built. And this project is essentially a kind of a self-contained set of folders, directories, and data products that ENVI LiDAR uses to read the LiDAR data. So this .ini file is essentially the metadata file that contains all the information needed for ENVI LiDAR to read this project. So if I just go ahead and drag this into the ENVI display, that'll pop up my LiDAR viewer and it'll actually load the image. And so here now we are in our ENVI LiDAR GUI. And this is a beautiful scene that was downloaded from the National Science Foundation Open Topography webpage. And so you can see we've got a beautiful scene here right up against the mountains. There's some buildings, some roads, some trails going up into the mountains. In ENVI LiDAR, in this interface, we have lots of visualization tools. As I mentioned, this used to be a standalone product that we sold separately. And there's lots, it's a full-featured, really, interface for working with LiDAR data. So there's a lot of different things we can do. You can see that this LiDAR point cloud actually has RGB values associated with the points. So we've got a nice color visualization of our scene. If that wasn't the case, a lot of LiDAR data sets don't necessarily come with these RGB values. We actually have tools for taking a multispectral image and applying the RGB values in that image to the point cloud that would be geo-referenced to the same area. So if you have any questions about that, let me know. We have some extensions for doing that we could get out to you. Also, we could very easily color this by height. And there's a lot of other tools in here. I don't really have time to go over all of them, but I just want to show an example of using our cross-section tool where we can increase the width, maybe move the angle that we're viewing the cross section. So there's a lot of tools here for simply visualizing and understanding our data. And a lot of these tools come in handy when we run some sort of processing and we want to do some sort of quality assurance, maybe do some cleanup on what the automated algorithms have pulled out of our data. That's where these tools come in really handy. So the next thing I want to show is the out-of-the-box LiDAR capabilities. So I'm going to go into my process window. So we have this process data dialog that we can pop up. And here's where we can take advantage of all of the algorithms that are available in ENVI LiDAR for processing our data. So you can see by default that the produce orthophoto, produce digital surface model, and produce digital elevation model checkboxes have been checked. If we have the ENVI feature extraction module, we can also extract buildings, trees, power lines. I'll show just an example of what that looks like later on. We can also reproduce a point cloud. So for instance, if we want to produce a point cloud, maybe tile it off by limiting the file size, there's a lot of different things that we can do to essentially manipulate our point cloud and reproduce it in different ways, maybe add classification values and then reproduce it that way. So for now, I'm just going to go ahead and produce the orthophoto, a surface model, and the digital elevation model. And let me go ahead and define an area here. I want to do a slightly larger area than that. So I've defined my area. If you had a shape file or some other vector file, you could choose what you wanted to subset the area by. And then we also have some production parameters. This is essentially a method for tweaking the algorithms that are doing the work here. So with the orthophoto, you can choose the resolution. You can choose the resolution of the digital elevation model down to 50 centimeters. So really fine-grained digital elevation model. And the same with the surface model. And actually, the surface model is now down to 5 centimeters, which is new in this release. So I'm going to go ahead and just start processing and let this work happen. And so you can see now that as this project is processing, we're essentially tiling off this image and getting to work. And within our project, we can actually start to see these products load in as the processing takes place. And we'll give this just a second, and then I want to pull these products actually into ENVI, into the main ENVI interface, and do a little bit of looking at them and manipulation. All right, so you can see we have our bitmap, which is essentially our orthophoto image, and we also have a digital elevation model and a digital surface model. All right, so processing is complete. We can visualize this in the ENVI LiDAR interface, or we could go back into ENVI, which is what I would like to do here. And let's go ahead and pull some of these products into the main ENVI interface. So we've got our bitmap, we've got a digital elevation model, and we've got our digital surface model. All right, so we've got these three products in ENVI now. You can see that our surface model shows the height off the ground, but it also shows the bare earth underneath. We've got our digital elevation model, which is just the bare earth, so all of the features have essentially been scraped off of the surface. And then we also have our bitmap. And so there's a lot of different things that we could do in ENVI with these products. So we've got a whole set of terrain tools within the ENVI toolbox, including a 3D surface view, creating a hill shade. There's a lot of different products. In our topographic modeling tool, there's actually, the ability to generate, I think, something like 8 or 9 different products from digital elevation models and surface models. So here, though, what I'm going to do is just I create this easy button. It's essentially just band math. It takes a surface model and an elevation model, and it subtracts the elevation model from the surface model and leaves us with a height model. So it tells us how high these features are off the ground. So let's go ahead and open our surface model, open our elevation model, click OK. And now we have a height model that was generated. And I guess my point in doing this demo is showing just how quickly these things can now be done within core ENVI. So very quickly, we've got a product that we've generated. And there's a whole lot more that can be done with this. When ENVI LiDAR classifies, it goes through a point cloud, it classifies the image. So if we know what has been classified as a building as opposed to trees or other features within our point cloud, we can then extract those features individually rather than all together. So there's a lot of really neat things that can be done, and this is where the power of the API also plays in, because we have programmatic access to our point cloud, so we can get really kind of original with our thoughts, really creative with what we're doing with our imagery. So, all right, the last thing I'm going to do is I want to show one other example. So this is the same LiDAR project that I'm going to show here, but I've actually gone ahead and run feature extraction. So you can see in my products folder, I now have from the same project, so it's the same LiDAR point cloud, but you can see in my products folder, I've got building shape files, I've got power line shape files, I've got power pole shape files, and I have tree shape files. So these are all 3D shape files that allow us to visualize the information that's been pulled out of our LiDAR point cloud. If I were to open this project in ENVI and give it a second to load, and if I were to view using our 3D viewer, which is essentially just a handy way to view what's been extracted from our images, it's not unlike maybe like an arc scene type tool. You can see that we've got power lines which clearly run through the point cloud. We've got our buildings that have been extracted, and we've got trees where we would expect trees. And of course, if there is some sort of misclassification, you can always go through and do some cleanup of what's going on in your imagery or in your point cloud, and you can also actually tweak the algorithms to say define what is a tree based on height and radius and those sort of things. So, okay, I'm going to go ahead and get back into my slideshow. All right, the next thing I want to talk about, I guess kind of keeping with this point cloud discussion, is the new Photogrammetry Module, which was really released just a handful of weeks ago. So this is really exciting. It's a new software technology for us, and it essentially offers the ability to generate 3D point clouds using stereo optical imagery from some of the more popular commercial spaceborne platforms. So this functionality is now a component of the Photogrammetry Module, which produces LAS format output files that can be used with ENVI's wide variety of point cloud visualization and processing tools. So this tool runs on Windows 64-bit platforms and does require a separate license for the ENVI Photogrammetry Module. This was formerly called the ENVI Orthorectification Module and does also include access to rigorous orthorectification. So why do we want to generate point clouds from stereo imagery? So first off, it allows users to take advantage of large commercial imagery archives. So if you've got this data, it's sitting around, it's available, you can use this tool to essentially get more product out of what you've got. You can also create point cloud and terrain products where flying airborne LiDAR might not be feasible or would be cost prohibitive. So this is a great way to maybe get a higher resolution DEM in an area where that is not available. So there's a lot of neat things that can be done with this. The Photogrammetry Module provides fast processing performance, excellent XYZ point cloud accuracy, and when a 3D point cloud is combined with multispectral imagery in ENVI, there's a lot of options which you can use to generate various different products. So at version 5.3, these are the sensors that are currently supported, though we do expect this number to grow with subsequent releases. These are the ones in this kind of first round of the Photogrammetry Module that have made their way in. And so the next few slides really just show a couple of examples that our engineers have given over to us as they were testing this product. They came up with some really just beautiful point clouds from multispectral and panchromatic imagery. And while I'm on that topic, I might as well mention that the higher the resolution, the imagery that you have, the higher the resolution of your point cloud. So if you have, say, imagery from Pleiad sensor or WorldView 3, and you've got that panchromatic band, that's going to give you the highest resolution result when you're generating a point cloud. So here's a beautiful scene over our hometown here out in Boulder, Colorado. And one last one of WorldView 1 over Saudi Arabia. So I'll very quickly go ahead and open up a ENVI LiDAR project that shows an example of a point cloud that's been extracted from Pleiad imagery. So here you can see, well, actually, before I do that, let me show you. This is essentially the interface that you work with. It's very simple. So you give it any number of input rasters. So if you're doing, just stereo pair imagery or tri-stereo imagery, you can enter 3 input rasters. Optionally, you can add a digital elevation model. If you don't add a digital elevation model to this tool, because that's used to essentially perform the photogrammetric corrections, if you don't add one, we do have one that ships with ENVI that will be used in its place. And then you have some additional algorithms that can be tweaked within the tool. And then you essentially just run the tool. And what you get is a number of output LAS files. And what we've done here is taken all of these LAS files, built a single project using our ENVI LiDAR capabilities. And let me go ahead and drag that into the ENVI display. I love doing that. And then it'll pop up here in just a moment, and we can see our point cloud, which has been extracted from multispectral imagery. So all right, let's go ahead and close out of that. Make sure ENVI's cleared out, and then I'm going to go ahead and get back into my slideshow. And we're going to move on to the 4th dimension. We've been talking an awful lot already about the 3rd dimension, which is our, our 3D capabilities, but let's talk about time. So ENVI now allows, or has for a couple of releases now allowed you to build a series of image, which we call a raster series, for spatiotemporal analysis, and then view these images incrementally using our series manager tool. In ENVI 5.3, what we've done is we've added several tools for converting images in a raster series to a common projection, common resolution, and common spatial extent, what we call a common grid. So ensuring a common grid allows you to perform true spatiotemporal analysis. For example, if you're studying change in vegetation over time, or the change in a glacier's extent over time in a specific location. So we've also added a series profile tool, which allows users to view changes in any given location throughout time. And so I'm going to demonstrate these tools briefly and talk to them in a couple of slides here. But what I'm going to do first is kind of dig in on this regrid raster series concept. At first when I was introduced to these tools, I wasn't quite sure their value. I didn't really understand because I hadn't used them. Like, why is this such a big deal? And so here's what I've come up with, and it's actually, now that I've gotten used to using this tool, it's actually kind of amazing to me what it does. And the reason is this: if we're going to do true multi-temporal analysis, we might have imagery from several different sensors. They might have different spectral resolutions. They more likely than not do not have the same extent. And they might not even be in the same coordinate system. In fact, they probably aren't going to be in the same coordinate system if I got them from different sources. And so what these regrid raster series tools allow us to do is essentially very quickly, very easily, using one simple tool, essentially take a set of images, whether it's 3 images, it's 10 images, or it's hundreds of images, and get them into a common coordinate system, get them into a common extent, and get them into a common pixel size. And so this is a very fast way to essentially improve, your optimize your processing workflow so that everything happens the way it should, so that you can then move on to the actual analysis portion of what you're trying to do. And there's a lot of different functionality depending on the tool you use. So I don't know, maybe you're working with images and you don't necessarily care if the extents line up exactly. So if that's the case, maybe regrid raster series by union would work. Or if you want to just regrid the series by the intersection of all the images, so you only want where they all overlap, then you can use regrid raster series by intersection. Or if there's a particular image within your series that you want to use for the regridding, then you can use regrid raster series by index. And then there's also just the general regrid raster series tool, which allows us to essentially create a custom grid. So it might be a hybrid of the extent of one image, the pixel size of another, and the coordinate system of your choosing. So I'm going to demo these tools in just a minute and kind of show you how powerful this is. But before I do, I just want to show off, this is our series profile tool. Down here, you'll see this is essentially the series profile in ENVI. And in this particular graphic, what we're looking at here is we've got MODIS, 16-day normalized difference vegetation index for an entire year across the Great Lakes region of North America. So we actually can use this series profile tool on a regridded set of raster images to dig into what any pixel value is throughout time. So what we're seeing here when we look at these various different profiles in our graph are what that pixel was looking at like throughout the year. So this allows us to get an idea of trends, to see maybe when change occurred in any given place, to understand how trends differ from location to location. So for example, you'll see our northern latitudes here. Vegetation is fairly low until sometime in March, and then shoots way up. And then in November, when plant senescence has happened, we see this drop straight down. Conversely, in our southern latitudes, it's higher throughout the year, doesn't get quite as high ever, and never goes quite as low towards the end of the season. So we can use this tool to really pick out trends that might not be otherwise available or visible to the naked eye. And so one other example of that here on this next slide is the use of this tool in precision agriculture. So we're out here in the United States, in the western United States, specifically in California. We've got drought. We've got terrible drought that is affecting everybody, and particularly the Central Valley of California, where there's a large agricultural industry. Being able to conserve water, to optimize operations is of utmost importance right now. And here's just one example of taking a look at an individual field. So we're using high resolution Pleiad imagery with 0.5 meter resolution, and we can see on May 3rd there's no vegetation in our field, which corresponds up here to my key. We see a little bit of growth on the 9th of May. By June 5th, we've got very high vegetation in many parts of our field. And then what we see here is by June 23rd that we're actually starting to see areas of crop loss in our field, and we've got stressed crop. And our series profile tool can really help us pick this out. So we can see steady growth up till June 5th. And then after June 5th, sometime between June 5th and June 23rd, not a single part of this field has actually increased its vegetation health. So this will help us kind of essentially see things on the ground that might not be, readily or things from the air that might not be readily visible from the ground. So let's go ahead and demo some of these raster series tools. I just want to show how easy it is to, number one, build a raster series, and then number two, regrid it. So let's go ahead and go into our spatiotemporal analysis toolbox, and we'll build a raster series. So All right, let's go ahead and pull in. I've got 3 images. These are all from the Sierra Nevada region of California. There was a rather large fire that burned outside of Yosemite National Park between August and September of 2013. So I've got a Landsat image from right before, a Landsat image from right after the fire, and then I have a Spot 7 image from pretty recently, back in June of 2015. So let's go ahead and open these 3 images. I'm going to choose to order the series by time. So we're going to take the acquisition time of these images and we're going to load them into the raster series in that way. And let me choose an output file name real quick. All right, so our raster series has been built, and this is really handy for being able to scroll through the images in our series. In the past, if you, let's say, this is just an example for a demonstration, but imagine if we had maybe 10, 20, 30 different images in this raster series. In the past, we would have had to manually turn images on and off in the layer manager. We could maybe use our portal window to view them. Now we can simply click through them in our series manager to get an idea of where they are in time and space. We can also quickly add annotation. So if I wanted the date and time information from the imagery, I could add that. So as I scroll through the imagery, that changes. There's a lot of other kind of neat little bits of functionality within this tool. At any time, we can take whatever raster is loaded in the series and we can load that to the ENVI display. We can also export. So maybe with 3 images, this wouldn't be quite so compelling. But if we had perhaps a raster series that contained, tens, hundreds of images, we could save this out to a video format. So we've got all sorts of kind of common video formats that we could export this to. So GIF format, MPEG-4, that kind of thing. So where this is really neat is if you do have some sort of atmospheric or weather data, if you're tracking a hurricane, say, or you're looking at anything of that nature, this tool can be really handy. So let's go ahead and cancel out of this. And I'm going to go ahead and load this raster. Let's go ahead and build. Here, let me remove the series metadata. And I want to go ahead now and regrid our raster series as I had mentioned earlier. So let's go into our regrid tools. I'm going to go ahead and regrid the raster series that we just built. So I'll grab my series file. And then here's where we can define our grid. So we're going to do it by coordinate system, the extent of an image, and a pixel size. So we can build this grid definition from one of our input images. I'm going to choose the Spot 7 image because that's got the smallest extent. So that just pulled in the extents of this image. The one thing I'm going to change here is that we're working with Landsat images, which have a 30 meter pixel resolution, and then also the Spot 7 image, which has 6 meter pixel resolution. I'm going to go ahead and change the Spot 7 to match the Landsat pixel resolution. And then I'm going to go ahead and output that to this directory. And so you'll notice as this is building, that we're actually regridding these files. So we're reprojecting, we're subsetting, and we're changing the pixel values for all these, or pixel sizes rather, for all these images. So you'll see that we have 3 new files that have shown up. So we've actually regridded our series. And so if I were to pull that into ENVI, let's get rid of these other guys real quick. Let's do a color infrared visualization. And now you can see that all 3 of our images have the same extent, they have the same pixel size. this allows us to do a much more in-depth analysis. And so real quickly, I'm going to show the series profile tool. The series profile tool will allow us to take any band from a multispectral image and display it in this profile. So let's go ahead and take the near infrared because it's a better indicator of vegetation. So here we've got the near infrared band. Let me go ahead and change the date format. There's a lot of functionality contained within all of our profile tools at this point, so we can really tweak these things. If we wanted to, create a legend, we could add whatever pixel values we have in here. If I wanted to add, a couple of more, we could add these to our legend very quickly. We can export this to PDF directly to a PowerPoint. We can print it. We can even add it as an IDL variable. So there's a lot of handy functionality within this. And as we click around our image, we can get an idea of where vegetation has changed, decreased, increased throughout the years. This isn't quite so compelling with the example I'm showing here because we've got 3 images. It kind of makes sense that before the fire there was high vegetation. Right after the fire there wasn't a lot of vegetation, and then it shot back up. But if you have lots of images, you can actually start to see trends, and that's where this tool becomes really powerful. So, all right, I'm going to go ahead and close out of those images and get back into my slideshow. All right, now we're going to talk about the ENVITask system. For those of you who are not familiar with the ENVITask system, it's a relatively new method for performing discrete bits of image processing programmatically through the ENVI object-based API. So it's very simple. So what's great about the ENVITask system is that it allows you to essentially take an image, pull it in, run some sort of processing on it, output that image either to a file or just output it into the next ENVITask. So we can pull things together to do true batch processing where we're selecting a set of images, we're running maybe radiometric calibration, atmospheric correction, maybe producing a spectral index or a classification image, whatever you want. So it's highly configurable, it's fun to work with. This was introduced in ENVI 5.1. In ENVI 5.1, I think we had 4 ENVITasks available. It was expanded in ENVI 5.2, and now in ENVI 5.3, we have over 135 ENVITasks out of the box that are available in ENVI. So they're simple. Just define the task you want to have called, define the parameters, and run your task. And so you can actually see this in this little snippet example of code here. I want to walk through this real quick. Essentially, we're just calling the ENVI object, which is a reference to ENVI itself. We're creating a list of files. We're calling the task that we want to run, in this case, spectral index. We're defining the index that we want to run because our spectral index task, just like our tool in ENVI, has, I think, something like 65, 66 different spectral indices that you could call. We're defining an output directory. We're looping through all the files in our file list and outputting our result. So that's how simple these are. And this allows for a lot of cool things because if we were to maybe wrap this as an extension, which is a pretty straightforward kind of thing to do if you follow our documentation, then we have all of a sudden a custom extension that does lots of things all at once. Or we could simply batch process. So real quick, I just want to show, this graphic is just meant to show you just how many different ENVITasks we now have available. And hopefully as you look through that list, these, if you're familiar with remote sensing, these are all kind of terms that might make sense. They kind of have names that are very self-describing, very easy to understand. So you can simply call these, run them, execute them, and get the information that you're looking for. So as I've already mentioned, this is great for batch processing. I use it all the time. Rather than clicking through our interface and doing all these things individually for each image, why not just do them all at once with maybe 10 lines of code or whatever we're looking at here. And then two, it's a little bit beyond what we're going to really be able to dive into during this webinar. But if you are familiar with working in the ENVI API, we do now have the ability to write custom ENVI tasks. So there's a lot of benefit to doing this because once it's deployed, it behaves just like any other out-of-the-box ENVI task that we have. And so this allows a huge amount of flexibility. So if you have a custom algorithm, maybe you wrote a paper or you read a paper and there was something that was done with a remotely sensed image, you can write that as a custom task, deploy it as an extension in ENVI, and it comes with this dynamic UI capability. So if your algorithm maybe takes 2 input images and it outputs 3 different files, then this dynamic UI that's built that kind of comes for free with this custom ENVI task framework, it'll essentially build that for free. It'll say, all right, I need 2 input images and 2 output files, and I need a little drop-down list that tells the user how to tweak the algorithm. Well, that's all kind of out of the box now with this custom ENVITask system. If you're interested in learning more about this, this is something that I do a lot with. I teach extending ENVI here in Boulder, Colorado. This is all part of that class. If you're interested in learning more about this, please contact me directly, and I can even give you some code examples like the one that I'll be showing here in just a minute. So let's go ahead and actually show a couple of things here. I'm going to exit out of here. We're going to get back into ENVI, and I'm actually going to maximize this time IDL. So this is the IDL workbench. We're not going to spend too much time coding here, but I just want to show a quick example of how we could do some batch processing. So you'll recall that when we regridded our rasters, we created 3 input, or rather output files that are in this file location. So we're going to go ahead and create a list of these files in that location. We're going to call our spectral indices task, which, by the way, I'm also going to mention here. This is very well optimized for Google. Our documentation center is very well optimized for Google. So anything you want to know about any functionality or feature within ENVI, Google it. This is a list of our ENVITasks. So these are all the tasks that are available in ENVI 5.3. This is all just on the World Wide Web. So you can find this in addition to the help documentation that ships with our product. You can find it in here. So here's, for instance, our spectral indices task. There's a code example that you'll notice looks very similar to the code that I'm about to run. And then there's also, explanation of all the syntax that goes into this. And then take a look at all of the indices that we actually have available in ENVI 5.3. So it's pretty impressive how simple it is now to run this processing. So let's go ahead and compile this and run it. And so now we're producing our spectral indices. You'll see that I've written my code so that these kind of pop up into the ENVI display. And so now we've got spectral indices, and each one of these image files, just by clicking go like that, I've created image files for all of our regridded images that contain 8 spectral indices, just because that's what I chose. So if I wanted to maybe load an optimized soil adjusted vegetation index, I could take a look at that. I could very quickly change my color table to maybe something that's a little bit more nice to the eye. So here we've got a color table where red is no vegetation, green is very healthy vegetation, and the yellows are something in between. So these are all really handy tools for working with multi-temporal data. It allows us to do things very quickly. And so that's the beauty of ENVI right now, is that we've really streamlined the process for our users. So and if I wanted to at this point, I could build a raster series now from these images, since they're already in a common grid. I've done some processing. I could then build a series out of these images, and then I'm actually looking at a processed result. So I could actually then take the pixel values for NDVI for all of these different images and compare them across time, and they would be they should be accurate across time in any given pixel location and the actual values that are contained within them. So the last thing I'm going to show with regards to tasks is a custom ENVITask. And I'm just going to go ahead and run one very quickly. Let me open a couple of images here. So you should be familiar with these images. This is the before and after from this rim fire that I mentioned. So you can see the burn scar in the after image, and then the prior image does not have that. I've got a number of custom extensions that I've built here. I'm going to go ahead and run this Landsat difference normalized burn ratio with threshold. And so here's my dynamic user interface. I've got a little bit of help that tells you what this custom task does. So it calculates a normalized burn ratio, then the difference normalized burn ratio, and then it thresholds that image. So for input, it's asking for a pre-calibrated pre-fire, pre-calibrated post-fire, and a couple of output images. So let's go ahead and run this. All right, there's my pre-fire. There's my post-fire. And then we're off. And hopefully people online kind of see the beauty and just how quick this is. This could all be done through the user interface by, if we were to go through those steps, essentially you would take your before image, you would do a normalized burn ratio, you'd do the same thing to your after image. You would then use some band math to subtract the burn ratio from before to the burn ratio after, and then you would use our raster color slice tool to threshold that output image. So what we just did is take all those steps and consolidate them into one handy tool that gives us an output image where we're viewing burn severity very quickly, and you can see the legend here. The way that I've labeled the classes coincides with burn severity. So if anybody has more questions about this, I could talk all day about it, but I probably have to move on now. So the last kind of portion of our webinar, and I know we're kind of running a little bit long here, but I'll try to wrap up here, is just exciting new features in ENVI 5.3. These are the things that I think are exciting if you're kind of a heavier user. If you use ENVI a lot, the little tweaks that make life easier for us. So one of my favorite new features is the ability to edit raster metadata. So it's a modern upgrade to the edit ENVI header functionality, and also the edit classification image, class names and colors. So as a quick example, I want to edit an ENVI header. In the past, this was kind of a clunky older tool that was ported over from what we call ENVI Classic. Now it's completely modernized. It's really easy to add metadata to a file or remove metadata from a file. So for instance, if we were working with an image that didn't have acquisition time, but we knew the acquisition time, we could easily add that through this tool. We can rename the bands in our image. We can add wavelength information to our image. We can add a data ignore value. So a certain value within the image will not display on the screen or will be ignored when doing processing. We can add a description. All sorts of things can be done in this tool, and we can also add a number of various different options. So this is a really handy tool for editing metadata. And then the other thing that I mentioned is that we can now edit class names and colors of classification images through the ENVI display. So if I just click on a classification image in the layer manager and say edit class names and colors, we get this new dialog that pops up. So I could click on any classification and change the value to something else, and I can maybe edit the color. And then my new result pops up. So this is, I think, pretty cool. A couple of other things that we've done. We've added a couple of new spectral indices. The normalized difference MUD index is very good for extracting information about shallow or turbid waters from an image. We also have the modified normalized difference water index. This is one I've used a lot, so it's very good at extracting open water from imagery. There's a lot of different use cases for that, whether you're looking at maybe where water is changed because of drought or maybe because of flood. The modified normalized difference water index is really good for getting that information out of images. We've also made updates to our atmospheric correction module. So the baseline quick atmospheric correction version has been upgraded. There's more information available about that on our website. We also we ship a GMTED 2010 global elevation data set with ENVI. If you are an ENVI user and you want it, we actually are offering on our webpage, because it's such a big file that we decided not to ship it with the product. I think it's about 1.5 gigs. There's a higher resolution GMTED 2010 global elevation data set that you can download from our webpage. So feel free to check that out. Last but not least, I want to talk a little bit about the IDL Python bridge. So this isn't quite ENVI territory, it's more IDL, but this has a lot of implications for ENVI, ENVI and ArcPy interoperability, that sort of thing. This is a new bridge that allows IDL to be called from Python and Python to be called from IDL. We are just getting our feet wet with this. We ourselves actually have a lot to learn about these capabilities, but we're really excited that our user base has already started digging in on this. We've been asked a lot of questions in our tech support group lately about this, and it's pretty exciting. I have just one very simple example that shows this in action. So here I just have a very simple IDL routine where I'm defining some IDL variables. I'm calling a Python module. I'm calling some methods on that module, and I'm creating a plot using Python, and I'm doing this all through IDL. So if I were to compile this and run it, I just created a graphic through IDL in Python. So this is pretty interesting stuff. There's a lot more to come on this. You can essentially install any flavor of Python that you choose, and then just set up your paths correctly so that IDL can see it and Python can see IDL, and then you're off to the races. So with that, I'm going to go ahead and go back into the PowerPoint slide and just bring you to this page so you can see what's new in ENVI, what's new in IDL. Here's some links to our Doc Center. Our Doc Center does have all sorts of information about, I can actually show you here, if you just go to IDL 8.5, you can see what's new in IDL 8.5. Same with ENVI 5.3, what's new. Very easy to get to on our webpage. So anything that I missed will be included in there. Thank you everybody for attending. I'm sorry we went a little bit long here today.